Hey guys, welcome to Projectile, Motion, and Physics. I'm going to tell you where this ball will land when dropped from that slide. To find out the projectile motion of that ball that we just saw before, we're going to have to know three equations. The first equation we're going to be using is to find the ramp, the equation for the ramp. And it's this one, D equals VI plus VF over 2 times T. Now, what those symbols mean are this. The D is the distance, so it's going to be the distance from here to here. Your VI is your initial velocity, which is your starting velocity. And for anyone who knows this, if you're going to take a look at this ball right here, your initial velocity is at 0. Pretty self-explanatory. Now, your final velocity is what you're going to be finding because you want to know how fast it's going to shoot off from this point right here and shoot off out onto the ground over there. And your time is pretty simple to do. You basically just track how fast this ball is going down the slide. I'm going to try doing this. I'm sorry, I'm working by myself here. And you can basically time how long it took to go down that slide. Now you have all the information. What I got from my information is with this. For my distance, I got 1.6 meters. For my time, 1.5 seconds. My initial velocity is 0 because, again, it's not moving at the beginning, so it has an initial velocity of 0. What I'm trying to find here is my VF. So by using the equation D equals VI plus VF over 2 times T, and just by plugging in the numbers, sorry, I have to move my pen, you get your answer. So what I got was 1.6 equals 0 plus VF over 2 times 1.5. I simplified that by dividing 1.5 on both sides, and you get final answer. You should get, and then what you do is to take out the denominator under the VF. You multiply 2 on both sides, and my answer was 2.13 meters per second for the final velocity. For the second part, what you have to do is you have to use the equation D equals VIT plus 1/2 AT squared. Now, from A is the acceleration due to gravity, and that's always going to be 9.8 meters per second squared. Remember that. You might have a test on it. Your D in my case, which I found out, is the D of Y, which is from that dot to the floor. And for that measurement, I got, let's see what I got. I got 0.3 meters. And again, my initial velocity is 0. The reason being for that is because to find for the D of Y, it's not going down until it starts from here. So it hasn't gone down anything, so your initial velocity hasn't hit anything, so you can only have initial velocity of 0 in that case. And so I plugged it into my equation, and I got 0.3 is equal to 0 OT plus 1/2 9.8 T squared, and then that keeps going, and you finally get your answer of 0.25 seconds. And now, the moment of truth has arrived. What you have to do is you plug it into your final equation, D equals VT. You know your velocity. Your initial velocity from the ramp problem now becomes your final velocity, or your initial velocity in this problem. So it's going to be 2.13. Your time you recorded at 0.25 seconds from the second part of the problem. You don't know your final distance of your x value, which is called your range. And to find out where exactly the ball will land from the ramp, from the bottom of the ramp, it should land, in my case, 0.5325 meters. So basically that's 53.25 centimeters. Alright, you guys, I don't know if you could see it, but here's the ball. I'm going to do the problem right now. I've laid a tiny piece of tape at the 53.25 meter mark, which we figured out was how far it was going to go and where it was going to land. So if my calculations were correct, and I hope they are, it should land approximately around that area. Alright, here we go. Yeah, there we go. Well, that's all the time we have for today, you guys. I'm Avi Solkoff, and I hope you guys have had a ball watching this movie. Bye.